Hi, welcome back. We're going to go over the process called factoring by grouping. Factoring by grouping is a great process to use, especially when we have more than 3 terms in our polynomial. The first step of factoring by grouping is to literally group, with parentheses, 2 different sets of terms, the first 2 and the last 2. At this point, we're going to be finding the GCF of both of those sets of terms, and we're going to factor it out just like what we looked at previously. In this case, the greatest common factor between x cubed and x squared is x squared. We pull out an x squared, we're left with x minus 1. Repeat the process with 2x minus 2. You left 2 times greatest common factor is 2. You're left with x minus 1. A nice little bonus, a little added feature of factor by grouping is there's a nice built-in check. When after this first step, you're left with the same expression, x minus 1, in both of our terms, you know you're heading down the right path. The reason why is that is now a greatest common factor. So we can pull that out of both terms, x squared minus 1. We're left with x squared plus 2. So our final answer can become x minus 1 times x squared plus 2. A lot of people have troubles recognizing that even though there are quote-unquote 2 x minus 1s, that's just another factor that we've pulled out and replaced with 1 x minus 1. It's a little bit difficult, but you'll get the hang of it. Let's take a look at our next example. This one's a little bit trickier, and not because just because of a simple step that there's a greatest common factor between every term. Between 2, 10, negative 10, and negative 50, there's a greatest common factor of 2. So we're going to pull that out before the problem even begins. 2 times r cubed plus 5r squared minus 5r minus 25. At this point, we can begin our grouping. Our first 2 terms, r cubed plus 5r squared. Now, this term's a negative, which makes it a little bit more difficult if we're having a subtraction sign there. So I'm just going to rewrite this as plus negative 5r, and we can group those two. Makes factoring, finding the greatest common factor, a little bit easier. The GCF between r cubed and 5r squared is 2. So we're going to, is r squared. So we're going to pull out the r squared. We're left with r plus 5. Greatest common factor between negative 5r and negative 25 is negative 5. So we're going to write plus negative 5 times r plus 5. What's nice is we have our little built-in check. Here it is, r plus 5, r plus 5. That expression is present in both of our terms, so we know we can use that as our greatest common factor now to pull it out. We're left with 2 times the quantity, r plus 5, and our remainder is r squared minus 5. If you want to write that in a slightly neater form, you can drop the brackets, just have 2 times r plus 5 times r squared minus 5.